Lesson 10.5 is about recursion and iteration. So we'll start with recursion. A recursive sequence is a sequence in which each term is determined by using either the previous term or the previous two or more terms. All right, so we'll start with a simple one. Number one, looking at it, we can tell it's arithmetic because it's just adding 7 to get to the next number. All right, so to write a recursive formula, you need three things. And you could look at number 2 as a model if you're wondering what the three things are. So first of all, we need an equation. We've done something similar earlier in the chapter. So when we wrote an equation, we would start by writing a sub n equals, all right, but it's going to be a little different this time. So because it's recursive, we need to refer to the previous term. So what is the term before a sub n? Well, we need to take n and decrease it by 1. So the term right before a sub n is a sub n minus 1. Right, and how do we get the next term? We take the previous term and we add 7. Now, if you were only given that blue equation, the problem is you wouldn't know where to start. You would know that you're just going to keep adding 7, but you wouldn't know where to begin. So you also have to provide a starting value. So A1 is 3. And then now you can say that the equation on the first line that we wrote can be used starting with n values of 2. So if we provide A1, we can use this equation to find A2, A3, A4, and so on. All right, for part B, this one is not arithmetic because it increases by 15, but then by 60. So there's not a consistent difference, but there is a consistent ratio. All right, so to get from 5 to 20, you multiply by 4. And then as you can see, it just keeps multiplying by 4 to get the next term. All right, so we write our equation to find an. All right, what do we do to the previous term? We take the previous term and multiply by 4. So when I multiply, I usually like to write the number I multiply in front of the variable expression. So I'm going to take what's before a sub n is a sub n minus 1, and that gets multiplied by 4. I have to provide a starting point. Otherwise, I don't know what to multiply by 4. So our starting point is 5. And now the equation we wrote can be used for A2, A3, A4, and so on. All right, part C, we know that is also geometric because they give R. All right, so we're going to take the previous term, multiply by the R. All right, we are not given the starting point, but it's pretty easy to work backwards. So if we know that we're going to multiply by 4 to go forward, you could also divide by 4 to go backwards. So you know that A1 is 1. And now we have an equation that can be used starting when n is 2. So number 2 is a little different because it refers to a previous term, but not the term right before the term we're trying to find, but it goes back 2 terms. All right, so we want to find the first 5 terms. So I'll just rewrite the first 2 that were given. A1 is 6. A2 is 10. And they tell us that the equation they provide can be used starting when n is 3. So we can use the equation to find A3. All right, so here's the equation I'm going to use. All right, so the way I find A3, right, so right now, if I'm trying to find A3, then n is currently 3. And then plugging into the equation, I do 2 times A. And then again, at the moment, n is 3. So we do 2 times A sub 3 minus 2, which means 2 times A1. And we were given that A1 is 6, so A3 is 12. All right, I'm going to move up here to find A4 using the equation. All right, so again, right now, n is 4. So n minus 2 is 4 minus 2. So we're looking for 2 times A2, which is 2 times 10, or 20. Right, and then for A5, so you can probably skip this step here. You can see that it just goes 2 terms back, so it's going to be 2 times A3, which is 2 times 12, which is 24. All right, so we found the first 5 terms of the sequence. All right, same directions for number 3. We're given A1, so I'm going to rewrite that. To find A2, I take the previous term and then I add 2 times n. All right, so notice this n matches that number. So for this one, since n is currently 2, I'm going to plug in 2 for n. And we know what A1 is. A1 was given. 2 times 2 is 4. So A2 is 4.5. To find A3, we take the previous term, which is A2, plus 2 times, and right now n is 3. So this is 4.5 plus 6, which is 10.5. Right, for A4, we take the previous term A3 plus 2 times n is now 4. So A3 was 10.5 plus 8 is 18.5. Right, A5 is A4. So I'll do this one a little different. I won't write A4. I'll just plug straight into A4. Plus 2 times n is currently 5. So 18.5 plus 10 is 28.5. All right, A1's given as 1. A2 is given as 1. To find A3, we do 2 times. All right, so this right here is the previous term, and then this is the term 2 before, the one we're looking for. So this one might be a little confusing because those are the same. They're both 1. So this is A2, the first one in the parentheses, and the second one is A1. So 2 times 2 is 4. Right, this one should be a little more clear, although A5 will probably be the best one. All right, so it's to find A4, we do 2 times A3 plus A2. So 2 times 5 is 10. And now to find A5, we do 2 times the previous term was 10, and the one before that was 4. 2 times 14 is 28. So important to recognize that if you're looking for AN, this is the one right before it, and then this is the one 2 before it. All right, for number 4, we have to write a recursive formula. 4A's kind of tough because it's not arithmetic or geometric. Notice the numerator never changes. It's always 1. So we have to figure out what's going on in the denominator. All right, so what I notice is that if you pretend there's a 1 down here, the denominator gets multiplied by 2, then it gets multiplied by 3, then gets multiplied by 4, then gets multiplied by 5. All right, so how do we make it so it multiplies by a different number each time? Well, so we could use a strategy similar to what you saw on 3A. All right, so in the first term, this is when n is 1. And then over here, n is 2. Over here, n is 3. Then n is 4. And over here, n is 5. And so if we could use those values, it makes it a lot easier to find the next number. All right, so I'll do the first 2 steps. So if we know that A1 is 1, well, what do we do to our A1? So we take the term before it, and it seems like we just divide it by n. All right, so for A2, we took A1 and divided it by 2. And then for A2, it looks like only the denominator got multiplied by 3. When you multiply only the denominator by 3, that's the same thing as multiplying the number itself by 1/3. All right, so if you continue to plug in, you'll see that this works. And we also have to say that this equation can be used starting when n is 2. All right, looking at part B, it's not arithmetic because it goes down by 2, but then from the second to the third number, it does not go down by 2. And then it's not geometric either. All right, so I'm wondering if we need to look at the previous 2 terms to get the next term. All right, so let's say we're starting with A3. So how do we get 2 using 1 and -1? So one way is 1 minus -1 is 2. All right, so let's try to figure out, could that pattern work for everything? 1 minus -1 is 2. What if I subtract these? -1 minus 2, that is -3. And then if I subtract these two terms, 2 minus -3 is 5. -3 minus 5 is -8. All right, so it seems like the way we could find an, and we got to be careful with the order, I took the term 2 before, and I subtracted the term 1 before what we're looking for. All right, we have to give some starting points. And then say that this equation can be used starting with n values of 3. All right, part C, they give you D, so we know it's arithmetic. All right, and working backwards, if D is 5, then A2 should be 1, and A1 is -4. So again, if you add D to go forward, then you subtract D to go backwards. All right, so our formula is an. The way that's found is you take the previous term and you add the common difference. All right, we need to know where to start. And we don't need A1 and A2. We can use this formula starting with n values of 2. All right, on the back, we're learning about iteration. Iteration is the process of composing a function with itself repeatedly. Right, we are asked to find the first 3 iterates for number 5. They give you x0. So by the first 3 iterates, they mean x1, x2, and x3. Right, so this process is pretty simple. The way you find x1, you take x0 and you just plug it in right there for x. So this is going to be 4 times 2 minus 5. 8 minus 5 is 3. And then to find x2, we take our last answer and plug it in. 12 minus 5 is 7. And then to find x3, we take our last answer, which was 7, and we plug that in for x. So x3 is 28 minus 5, which is 23. All right, so for number 6, to find x1, plug in -2 for x. -2 squared is 4. 4 minus 4 plus 1, that is 1. To find x2, we take our last answer, which was 1, and we plug that in. Right, so x2 is 1 plus 2 plus 1, that is 4. x3, we take 4, plug that in for x. 4 squared plus 2 times 4 plus 1, that equals 16, plus 8 plus 1, which is 25. For number 7, the way we find x1, we plug in x0, which was 1, in for x. Right, so the numerator is 0, the denominator is 3. 0 divided by 3 is 0. For x2, plug in 0. Negative 1 over 2 is negative 1/2. And then for x3, take our last answer and plug that in for x. All right, the top is negative 1/2. The bottom is positive 1/2. So that equals negative 1. All right, for number 8, we have a figure shown, and then we're going to replace each side of the square with the combination of segments below it. So basically, this side that was 3, it turns into this thing. And that total length there was 5. You see 5 1-inch segments. All right, so the first question is, what is the perimeter of the original square? Well, a square has 4 sides. Each side was 3 inches long, so that square had a perimeter of 12 inches. All right, the perimeter of the new shape, so you could just count it. So I'm going to trace it. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so the perimeter of the new shape was 20 inches. All right, if we repeat the process by replacing each side of the new shape by a proportional combination of 5 segments. All right, so proportional, that implies that a ratio is being used. They want us to find the perimeter of the third shape. All right, so if we know that a 3-inch side is going to turn into this segment that has a total length of 5 inches, we know that our R is 5/3. So that makes our third perimeter 20 times 5/3, or 100 over 3 inches. All right, so what function can you iterate to find the perimeter of each successive shape? All right, so let's write f of x, since it asks for the function in that form. And we're just going to take our previous term and just multiply it by 5/3. All right, so remember for this process, it's a little different. They have to tell you what x0 is. And I don't actually know what x0 is yet. I know that x1 was 12, so I can work backwards. If I know that x1 was 12, and if I know I'm multiplying by 5/3 to go forward, to go backwards, I can divide by 5/3. Dividing by 5/3 is the same as multiplying by 3/5. Right, so working backwards, I know that my x0 is 36/5. All right, and that is all we need to write the function.